Now, with quantum computing, there may be a lot of questions, and I hope there is, because I'm here to answer them. One of the biggest questions is, well, what really is quantum computing? Is quantum something you heard from the Avengers movies? Is quantum something you might have heard from another science fiction movie? Well, I'm here to tell you, it's more than just fiction. Quantum computing is a process of computing, like regular computing, except the quantum aspect. The wires that are near the prism then connect them so that they'll not only fuse together, but hopefully make another chain reaction back to the prism. The prism is like a circuit. It keeps on going on and on and on. But with my project, it might have just improved that to a whole other level. Now, the reason I chose this is, well, because I'm creative. I like to create, I like to modify things, and I've always had an interest in the building blocks of life since I was little. When computing and building blocks of life come together, you get a quantum computer, and that's exactly what sparked my interest. Is I do want to become an entrepreneur for a company that I want to make that will improve the economy digitally, but we'll talk about that later. But the main reason is because I'm creative. I'm a kid who wants to create, who needs to create, and who needs to modify things every single day. It's just my fix. The real reason I chose this quantum computing thing is because I got interested in it. I was reading about how light travels in a brachistochrone, the most efficient way for anything to travel. If one thing goes down another line, even if it's straight, or even if it's a vector the same size and same area, the brachistochrone will always win, no matter what. If you cut that into 1.618 of it, aka the golden ratio, cut that ratio in half, you get the you don't get the cycloid, you get the brachistochrone, the fastest shape and the shape in which light travels. This is also why light reflects off of water. But why exactly did I choose it? Well, I realized it then produces electrons in two separate fields with the same amount of energy. So essentially it breaks the first law of perpetual motion. Energy cannot be created or destroyed. It breaks that law by saying, hey, you know what, I'm going to do both, and stares them in the eyes until they say, okay, you win. Now, I also like to think of this as a new computing system and systems for the servers that I want to run on a company that I want to fund, Livestock. Livestock would be a virtual banking system in which the economy would be inflated by 0.002% with that dollar. That dollar would be inputted and said, hey, okay, it goes from the magnitudes of both poles on the Earth, tracks them, and then translates them into the electrons so that you will get the exact area and location of the nearest satellite banking system in order to make sure that it's in the exact same zone as that economy. So basically, if everyone gets a Livestock account and it tracks that in America and people try to manipulate that, it's not going to work, because you won't manipulate it by having a bunch of magnets go around, because you cannot equate the magnitude of, well, the Earth and the poles of the Earth with a couple of magnets. So it's just not going to work. And also the amount of frequency that it would be vibrating at. It's just impossible to get it to the exact amount of hertz with that amount of power. It's foolproof. And guess what? It's also a great way to bank. I want to make this a real thing, and with quantum computing, I could actually see that as a possibility. Not only would it be more efficient, but it would also be more stable, less hackable, and best of all, it would not cost any inflation on every different economy, and there's no way to mine it at all.